Today we're going to talk about lesson 3-3. Specifically, we're going to be focusing on what happens when you have a negative underneath your square root. Up until this point, you guys have always been told you can't do that. It's not a good thing. It's not a real number. All of that is true, except now we're going to learn what we do if that happens. And in order to do that, we're going to have to use our imagination. Pause for laughter. Okay, basically, this is how imaginary numbers are created. We've talked about our real number system before. Okay, your imaginary number system is on the opposite side of it. Numbers are either real or they are imaginary. Okay, so we're going to introduce a new part to our new number system, which is where we're going to deal with negatives underneath the square root. Then we're going to learn how to do operations with these numbers that we find. So, starting out, what are imaginary numbers? Imaginary numbers are numbers that are in the form of bi. So, like 7i is an imaginary number. Okay, what do you guys think that I stands for? I don't know for sure, but I'm assuming that it stands for imaginary. It's letting us know that that number is an imaginary number. It's not real. How do we get imaginary numbers? When we have a negative underneath the square root. The only time that you're going to get an imaginary number is when there is a negative underneath the square root. Then, the building block for all imaginary numbers is this right here. Square root of -1 equals I, and that is 1i. Okay, and that is our building block that we are going to use throughout this for any of our numbers, any of our imaginary numbers. Okay, this is the first time you guys have watched a video. I meant to say this at the beginning, but remember, you guys can pause, you can rewind, you can do anything you want with this video to get your stuff down. Okay, so make sure that you guys are understanding what you're doing. Write questions off on the side if you have them, then you guys can come in and see me when you get back. Okay, so starting out, okay, I have the square root of -49, and we're going to go over how do we figure out what the square root of -49 is. Okay. Back when you guys had Mrs. Ernett, okay, you guys learned how to simplify square roots, and what you did was you used a property that said if you had two numbers times each other underneath the square root, you could separate that square root up. Okay, and we're going to do that to figure out what the square root of -49 is. So the first thing I'm going to do is if I have the square root of -49, I can split that up into two numbers. I can make that a positive 49 times a -1. Okay, so back up here with our property, okay, since I've got two numbers multiplied times each other, I can therefore split these up. I can split this up into a square root of 49, and I can split this up into a square root of -1. Okay, we know what the square root of 49 is. The square root of 49 is 7. And today, if you look back at your previous slide, we just learned that the square root of -1 is I. Okay? So I have a square root of 49 times the square root of -1. Well, that's simply just a 7i, or 7 times I. Okay? Now, those of you guys that might be looking at this might think, oh, that seems like a lot of work to do something really simple. And it is, and you don't need to show that work. What I do when I see this here, I see, okay, I got a square root of 49. I know that's 7, so I'm going to write 7 down. And then I've got a negative underneath the square root. What does that negative underneath the square root mean? Well, that means that I need to put an I at the back end of it. Okay, so if we flip to the next slide here, I've got a bunch of different examples. Okay, I've got a square root of -4. Okay, square root of -4. Well, what's the square root of 4? 2. And then I've got a negative underneath the square root. That means that there's an I on the back side. Okay, pause the video and see if you can write down the answers for these last three. Okay, on to the next one here. Square root of -36. Well, what's a square root of 36? Well, that's 6. And then that negative underneath means that there's an I. Square root of -81. Well, I know that there's a negative underneath, so there's going to be an I at the back end of it, and square root of 81 is 9. Square root of -64, negative underneath, I'm going to have an I. Square root of 64 is 8. Okay? So it's that simple to find your imaginary numbers. There are some more complex ones, but we are going to look at those when we do our 3.5 and 3.6 lesson. We'll get to those and talk about them then. So, complex numbers. Well, what are complex numbers? Well, complex numbers are going to have imaginary numbers, Okay? But then they're also going to have a real part to it. Okay? So if you look here, here is the standard form for an imaginary number. Okay? And if you guys look, you've got a BI, you've got your imaginary part in there, but then I also have this A. Okay? And that A is going to be a real number. So complex numbers are a combination of a real and an imaginary number put together. What you guys need to know about our standard form is that all answers must be in standard form. Okay? All answers have to look like that. So essentially, when you guys are working through these, work through them, do whatever you want, but then you have to remember for your final answer, the I part has to be at the back side of it. Okay? So let's practice. We're going to start out with operations with complex numbers. Okay? To add or subtract complex numbers, you're going to add or subtract the real part, and then add or subtract the imaginary part. What I want you guys to think of, if I see this first problem on here, okay? Think of I as a variable. So we're going to think of I as a variable, which means we just need to combine like terms. So we're going to think of our I as a variable. We just need to combine our like terms. For this here, I've got 11 plus 2i plus negative 6 minus 7i. I don't need those parentheses there because we just have a plus sign in between them. Okay, there's no reason to have those parentheses. So I'm just going to combine my like terms. I've got a negative 6 and I've got an 11. 11 and negative 6 gives me 5. I've got a positive 2i and I've got a negative 2i. So that's going to give me a negative 5i. And that's my answer. You just added two complex numbers together. All that we're doing with adding our complex numbers together is you're just going to combine like terms. Now if I ask you to subtract those terms, whoops, there is going to be one little trick that you have to remember when you subtract, okay? And that would be, can I get rid of these parentheses right off the bat? No. I've got a minus sign there. So my first step is, since I'm subtracting, I'm going to need to distribute that negative. So I'm going to have 8 minus 4i minus 8 plus 16i. Okay, minus 8 plus 16i. So when I do that, I have an 8. I have a negative 8. I'm going to combine those together. That gives me nothing. I've got a negative 4i, and I've got a positive 16i. So negative 4i and positive 16i gives me 12i. Okay? Again, you guys can pause, you can rewind, go back if you don't understand what's going on. Okay? Write down your questions, and I can answer them later. Okay. Then, whoops. Actually, before we do this slide, let's skip on to the next one. Okay. Let's skip all this stuff. I don't like the order of this. We'll come back and do those. Don't worry, you don't need to pause them. Okay, so let's talk about multiplying complex numbers now. Okay, again, remember I told you guys to treat the i's just like variables, which means if I'm going to treat these just like variables, I need to FOIL this. Okay, I cannot add 1 and I together. They're not like terms. But what I can do is I can FOIL this. I can take 1 times negative 9 to get me negative 9. I can take 1 times negative 2i, which gets me negative 2i. I can take I times negative 9, which gives me negative 9i. And I can take I times negative 2i. Now, we haven't done this before, but we said we treat these just like variables. So if I took an x times a negative 2x, we'd say that was negative 2x squared. Okay? So if I take an I times a negative 2i, that's just going to be a negative 2i squared. Okay? We've got an I squared. Not a big deal. All right? Now, after you guys finish foiling, then we would combine our like terms because we treat this just like variables, and I get negative 9 minus 11i minus 2i squared. And then is that my final answer? No, that is not my final answer because it's not in standard form. Okay? And I wanted to show you guys this before we went back to that last slide, because that's not in standard form. And all of our answers have to be in a standard form. And what that tells me is I can rewrite this I squared. So we need to go explore and see what I squared actually equals. Okay? So we're going to go back to that chart that we had drawn up here. Okay? And that chart we had drawn up, we've got I to the first power, we've got I squared, we've got I cubed, we've got I to the fourth. Okay, so starting out with I squared. Okay, I already know I equals I, but what does I squared equal? Well, I want you guys to remember that before we said that I equaled the square root of -1, correct? So if I have an I squared, I could rewrite, instead of saying that's I squared, I could say that's square root of -1 squared. What's that squared and what's that negative, or sorry, let me say that again. What's that squared and what's that square root going to do? Well, those two would cancel each other out, and what that tells me is, that tells me that I squared equals -1. I squared equals -1. Okay? Then we can use that pattern that we've discovered to answer what all of these other powers of I are going to equal. Okay? So starting out here, I've got an I cubed. Remember, these work just like variables. So I could say that I cubed would simply be an I squared times an I. Because if I added those exponents together, 2 plus 1 would give me 3. Well, we just discovered from our previous example that I squared also equals -1. So essentially what I have here is I have that an I cubed doesn't equal I cubed, and I cubed equals a negative I. And I can follow a similar pattern. We fill that in with our chart above. I cubed equals -I. I can follow a similar pattern with this I to the fourth. And your I to the fourth is going to turn out to be a huge one. Okay? I to the fourth would be the same thing as I squared times an I squared. And we just discovered that I squared is -1. So essentially this is -1 times a -1. And what is -1 times -1? Well, that would be a positive 1. So that tells me that I to the fourth is 1. And the reason that that is so important is because 1 is a super easy number to work with. Because what's anything times 1? Well, it's just going to be itself. So when I get to these other ones over here, I to the fifth, I to the sixth, I to the seventh, I to the eighth, we're going to figure out something kind of neat about this. I to the fifth could be rewritten as I to the fourth times I. Why is that significant? Well, we just discovered that I to the fourth is actually just a 1. So I to the fifth really is just a 1 times an I, which gives me an I. So my pattern starts all over again. I to the fifth just equals an I. When I do an I to the sixth, I can say that I to the fourth times I squared. So really that's just a 1 times I squared. And we know, because we just found this out, I squared actually equals -1. So that's a 1 times -1, which gives me a -1 for my answer. So my pattern is continuing on. I squared and I to the sixth both equal -1. When I do I to the seventh, that's an I to the fourth times an I cubed. So that's really a 1 times an I cubed. And we discovered that I cubed is actually just -I. So 1 times -I is just -I. So I to the seventh also equals -I. Same thing for I to the eighth. That's just 2I to the fourth being multiplied times each other. That's a 1 times a 1, which gives us a 1. That pattern continues. And if you guys keep following this pattern, you discover that I to the ninth is going to go here, I to the 10th will go here, I to the 11th, I to the 12th. And that pattern will keep going, I to the 13th, and so on. Okay? So what we're going to do is we're going to talk about here on this next PowerPoint what to do when figuring out a power of I.